Crater Lake caldera. What you're looking at is one of the planet's most impressive examples of a fascinating geologic formation. Known as a caldera, this specific feature called Crater Lake in Oregon formed a mere 7,700 years ago when a 12,000-foot or 3,660-meter tall volcano completely collapsed due to one of the planet's largest recent explosive eruptions. This drained the volcano's underlying magma chamber, leading to the ground overlying how calderas form, volcano collapsing downwards, which formed a massive depression in the ground, much like a sinkhole. Other calderas can be found around the planet and originate in eruptions which are typically at least 10 times larger than the 1980 eruption of Mount St. Helens. In the United States, not all of the calderas within the country exist on the West Coast. In fact, one ancient caldera exists in the state of New Hampshire. A caldera in New Hampshire. The caldera in question is located in the central eastern part of the state, where it is 6 miles south of Tamworth. There, the entire Ossipee mountain range is enclosed in an area which has a roughly circular shape. This shape corresponds to the ancient rim of its caldera and a series of ring dikes, which measures 9 miles or 15 kilometers wide. Although this land was once a giant hole in the ground, it now appears raised as the weaker rock around the complex eroded away, while the at-depth volcanic rock, which was highly resistant to erosion, remained. Today, the vast majority of the complex is filled with granite, which represents magma which was once part of its vast underlying magma chamber and related intrusion of molten rock that never reached the surface. 124 million years ago. Approximately 124 million years ago, the climate of New Hampshire was far warmer, and best resembled that seen in Florida today. Lush forests covered the landscape, and herds of large bird-like reptiles known as dinosaurs roamed the landscape. Also, widespread volcanism was ongoing due to an underlying hotspot in the mantle. Movement of the hotspot. This hotspot first appeared 214 million years ago, producing a series of highly explosive gas-rich eruptions near Rankin Inlet in Canada. These eruptions deposited volcanic pipes which contained a diamond-bearing rock type known as kimberlite. Over many millions of years, the crust overlying this hotspot moved to the northwest while the hotspot remained relatively stationary. The hotspot went on to form new volcanic chains throughout Canada, including the rounded Monteregion,